In this video, we are going to be working with the logistic growth model, which is similar to the exponential growth model as well. So, in this scenario, we have different heights of toothpick houses. In this scenario, we're given the variables x and n, where x represents inches and n represents the number of buildings which are taller than the set number of inches. So taller than whatever x we are going to use. So we're going to write down our data down here. So x is on top, n is on the bottom. So our axes are going to be 65, 66, 67, 68, 69, 70, 71, 72, which is just 6 feet, 73, 74, 75, and finally 76. And now we also need to label our n term as well. And our n terms are going to be 197, meaning that there are 197 buildings which are over 65 inches. In this scenario, in this first column, 66 is going to be with 195, 67 is going to be with 184, 68 is going to be with 167, 69 is going to be with 137, 70 inches is going to be with 101, 71 is going to be with 71, 72 is going to be with 43, 73 is going to be with 25, 74 is going to be with 11, 75 is going to be with 4, and finally 76 is going to be with 2. Given our x and our n, we are told to construct a scatter plot. So first step is to construct a scatter plot. Now, we are going to denote our n values using this bluish color, and we're going to denote our x values using an orangish color, more like a red. And so our first step, as we said, is to construct a scatter plot. So a scatter plot looks something like all the dots, the data. So this would be our x, this would be our n. It looks something similar to that. In this scenario, we're going to be constructing an exact scatter plot or an estimated scatter plot based on the data. So we have an x and y axis. We're going to be in the first quadrant since all our numbers are positive. Represent our x down here and our n up here. Again, n is blue, x is orange. Now, we are going to take this data. I'm going to take 3 of the points, 66, 71, and 73. So first we'll look at our x value because that's our x-axis. So we have 66, 71, and 73. They're pretty close together, so I'm just going to put them right here. 66, 71, and 73. All 3 points all have n values, and our n is going to be our y-axis. So our n values are 195, 71, and 25. So we have 195, which is going to be in the top of our spectrum. So we have 195 with 66. We have 71 going with 71, which is going to be right here. And we're going to have 73 going with 25. 25 is going to be right here. And you can see it forms almost like a line, a bit of a curve. Since it's a scatter plot, you'd usually have a line of best fit, which is pretty close to all the points. And in a real world scenario, you'd actually construct a real scatter plot using every single point, or you could use a scatter point calculator from online. Well, that's how you make the scatter plot. Pretty simple, pretty easy. The next thing that we want to do is we want to find how many of our buildings are over 65 inches. So how many over 65 inches? That's what we're trying to find out. So if we perform a logistic regression of these calculations, we should get an equation looking like 207 over 1 plus parentheses 1.285 times 10 to the negative 21st e to the power of 0.686x. You may be asking how we got this. So basically what you do is you could find a online regression calculator and just substitute all these values in, and it should give you an equation like this. Or what other people do, you can use an Nspire or a TI-84 and do the same thing with the regression. And this is the equation that you should be getting. So using this, we want to find how many of the buildings are over 65 inches. And remember that this equation is going to be equal to n of x. So n of x is basically the number which are over 65 inches. Because remember, x was our inch value, and that is our inch value. So now, and then that is the number over that inch value. So now what we will do is we're going to have the equation 207 over 1 plus parentheses 1.285 times 10 to the negative 21st e to the power of 0.686 times our x value, and our x value again is our inches. Our question is asking for inches, so we're going to substitute 65 here. That's going to equal our n of x. N of x is the number of buildings taller than 65 inches. After substituting 65 in as our x, we can put this into a calculator directly, as we see here, 207 over 1 plus parentheses 1.285 times 10 to the power of negative 21 parentheses e to the power of 0.686 times 65. After entering this equation into the calculator, we should get a value of 201.0115415 around. And you obviously can't have 0.0115415 of a building. I personally would write it as 201. That you have 201 buildings which are over 65 inches. You could also write it as just 201, or you could write it as 201 to 202, because obviously 201.0115, etc. is in between 201 to 202. So you could say 201 to about 202 buildings are over 65 inches. So that is how we would do number 2, which is our second problem, and the answer to our second problem is in inches, so we'll color code it red. So 201 to 202. The scenario we already labeled our n and x. Our last part of dealing with growth model. Our last part of dealing with the logistic growth model is going to be step 3. And in step 3, it asks that the tallest 90 buildings are grouped together. Okay? Are grouped together. We want to find the minimum height of these 90. So let's say you have 90 buildings. Out of these 90, what's the shortest height? To do this, we're going to use the same regression equation we found up here. And so that was 207 over 1 plus parentheses 1.285 times 10 to the power of negative 21 times e to the power of 0.686 times our x. And it's going to equal n of x. In this scenario, we're looking at n. And remember, n is going to be our y, right? We labeled n as our y, so that's going to be our y. So since n of x is our y, and it's asking about n, because remember, n, as we stated up here, is the number of buildings which are taller than our x. We want it taller than 90. In this scenario, we want to find the shortest out of our group of 90. In order to do this, we have to set this equation equal to 90, because n of x is our number over a certain, and we don't know that certain x, so we're solving for that x using this equation. So I'll just copy this down here. So now we will just solve for x. So we have 207 over 1 plus 1.285 times 10 to the negative 21st e to the power of 0.686 x. Now that we have 207 over 1 plus parentheses 1.285 times 10 to the power of negative 21st times e to the power of 0.686 x. Now we have this. We are going to be multiplying both sides by 1 plus parentheses 1.285 times 10 to the power of negative 21st parentheses e to the power of 0.686 x equals 90. So that's the equation we have. We're going to multiply by our denominator on both sides. So we're left with 207 equals 90 times 1 plus 1.285 times 10 to the power of negative 21st e to the power of 0.686. This right side, or in the parentheses, could be simplified down to 1 plus 1.285 over 10 to the power of 21st times e to the power of 0.686x. Now that we have this is being multiplied by 90, think about those parentheses, equals 207. We're now going to divide both sides by 90, just get rid of it, and we have 207 over 90, which simplifies down to about 23 over 10, which equals 1 plus 1.285 over 10 to the power of 21st, e to the power of 0.686x. Given this, we are now going to subtract 1 from both sides, just to make it simple on the right side. And we're trying to isolate x, obviously, so we have 23 over 10 divided by minus 1. So now we have 23 over 10 minus 1, which is just 13 over 10, equals 1.285 over 10 to the power of 21st, e to the power of 0.686x. So now that we have this, we're going to multiply our denominator to both sides. So we have 13 times 10 to the power of 21 over 10. So now that we have 13 times 10 over 21, because we're multiplying 10 over 21 to both sides, and we brought it down here, so now we are left with 1.285 e to the power of 0.686x. Next logical step to do is divide by 1.285 on both sides. So divided by 1.285, divide by 1.285. These cancel out. We are left with 13 times 10 to the power of 21 over 10 divided by 1.285, I know that's a big fraction, equals e to the power of 0.686x. Now, we're going to simplify 0.686x. This fraction simplifies down to 1.01167 e times 21. E, capital E, represents 10, and the 21 represents the exponent, which is the 10, which is our e, is being raised to. So it's basically 1.01167 10 times 10 to the power of 21. Obviously, that's not exact. There's a lot more decimals going there. We're just going to leave it at that for right now. And so what happens now is, this is still equaling e to the power of 0.686x. We're going to apply our exponent rules. I will be making a video on exponent rules soon. Now we're going to apply our ln to both sides, and I'll be making a video over when to use ln and when to use log in a future video. But in this scenario, we have e, meaning we're going to use ln. So we have to apply ln on both sides to get rid of this e. So we have ln of 1.01167 ... times 10 to the power of 21st, which is being equal to ln e, because the base of ln is e, which is around 2.72, and that's e 0.686x. Basically, when you have ln with an e right here, it basically eliminates, and you're left with this being equal to 0.686x. Our right side is just staying the same. And since our right side is staying the same, we can just bring it down. And after simplifying, we're now going to divide both sides by 0.686. And so we divide by 0.686, which cancels out, and which eliminates, and we are left with x. This is going to be divided by 0.686. So we have ln, parentheses 1.01167, times 10 to the 21st, over 686 equals x. And if we put this into a calculator, we get a value of x being equal to 70.50421, which I would round to about 70.5. And remember, we are in inches, so this would be orange. And that is how we would find the lowest height out of a group of 90. You could substitute any number you want out of the group, and that's how you do it. We did a lot of work in this video. I hope it helped, and if you do believe it helped, please remember to like and subscribe. And if you have any requests for future videos, please feel free to leave it in the comments. Thank you so much.